Welcome to the world of quasiparticles. Yes, today's topic of discussing is quantum spinons. Spinon. This is what? This is actually a quasiparticle. This particle is not like electrons or protons. You know, electrons and protons, those are physical particles. But spinons, these are not like electrons or protons. Okay, so where you will find this thing? In the study of quantum physics, that means more specifically quantum spin systems. If you study quantum spin systems, then in that case you will find these spinons. These are quasiparticles. You know, if you take a bar magnet, means if you take any magnet, or if you take any classical magnet, and if you cut that magnet into number of pieces, then each piece will show the dipoles, means both the poles, north pole and south pole, each piece, whatever be the size of the piece. Okay, each pole always will show you both the north and south poles. That is known to you, and that can be explained by classical physics or classical magnetism. Okay. In that case, magnetic field spans in both the sides due to the presence of magnetic dipoles. Okay, but in case of quantum spin systems, if you talk about a spin chain, then in that case something else happens, something different happens. And this is what? This is quantum world. And whatever happens here cannot be explained by classical physics. Means there you will find, in the quantum world, you will find the breaking of the rules of classical physics. So suppose you have taken a quantum spin chain system, okay, and so there is what? Number of atoms are there, and they are all aligned, number of atoms, okay, and each atom has their own spins. That means spins are actually aligned. Now, if only one spin of any atom is flipped, then what happens? So, whenever the spin of an atom is flipped, that means you are creating a disturbance into the system. And that disturbance comes out as the production of two quasiparticles. Yes, two quasiparticles. And both are what? Both are known as spinons. Each particle is a spinon. Okay, spinons is the plural form of spinon. Anyway, so two quasiparticles are produced, and each one has a different pole. One will have a north pole, another one will have a south pole. They both carry energy, but not the magnetic dipole, or they do not carry the charge like electron. Electron carries energy as well as its negative charge. You know this thing. But in case of spinons, they carry energy with them when they are moving from one place to another, or along the chain. In case of quantum spin chain system, along the chain they move. But here, both the quasiparticles move independently, but they carry energy with them, but not the charge. That means not the magnetic dipole. Here you will find the separation of the north pole and south pole. Normally, in case of classical magnetism, you know that the north pole and south pole are inseparable. They cannot be separated by any means. Okay, so there is a difference between classical magnetism or classical physics and this quantum world or quantum physics. Here also we are studying magnetic properties. Okay, so this is the difference between spinons and that means spinons are magnetic particles, these are quasiparticles, these are what? These are actually excitations. These are excitations of the system. That means these are actually disturbances of the system. Okay, these are excitations of the system, and these excitations are known as quasiparticles or spinons. Quasiparticles, these are nothing but categories. There are more quasiparticles, you know, those things like magnons, excitons, all those things are there. Means various types of quasiparticles are there, and here we are talking about only spinons. So this is the difference. And if you talk about implication of yes, implications are there. In case of quantum computing technology, scientists are trying to explore this property. And this is known as emergent behavior. Not only quantum computing, but many types of quantum technologies. Okay, scientists are exploring this property, and this property is known as emergent behavior, because this is not the property of an individual particle of the quantum system. This is the collective behavior. That means this is the outcome of the interactions between the particles in the quantum system. Okay, so quasiparticles here, spinons, are resulting from those interactions of the quantum particles in the system. Interactions, okay. So that's why these are called emergent behavior. And this behavior is different from other things. This behavior is unique, and whatever happens here in this case cannot be explained by classical physics. You need to know quantum mechanics. Here in case of spin chains, all the spins remain entangled, and you know quantum entanglement, so all these spins remain entangled. So whenever there is a disturbance in, I mentioned what? Flipping of a spin. So whenever you are flipping the spin of an atom, that means you are disturbing the state of one particle. Immediately the disturbance you will notice in all the particles of the system, because they are entangled by the principle of quantum entanglement. They are linked by the principle of quantum entanglement, or they remain interconnected by the principle of quantum entanglement. Okay, so this is the difference from classical physics. Anyway, sound is coming from outside. Anyway, ignore that noise. So this was all about today's topic. So here you can see what you have watched here. There is a breaking of the laws of classical physics. Okay, and these are known as quantum spinons, are only in spinons. Why quantum spinons? I am saying because this you will find only in the quantum world. Okay, in the classical world you won't get this thing. Only in case of a quantum world you will get these spinons. That's why these are called quantum spinons. Okay, special materials are there where you will find these properties. Okay. Anyway, so like a quantum spin ladder is one of the examples of such material. So in case of magnetic materials, this is studied again. To study the quantum physics in detail, the study of these spinons are necessary. Okay, to develop new technologies, the study of these spinons are necessary. Okay, anyway, so this was all about it, today's topic, quantum spinons. This is the end of this video. Thank you for watching this video.